Alright, so this example of using the power rule to find tangent lines is going to work very much similar to the last example, where we were only given an x value, but we were not given a y value. So here we're looking at the function x cubed plus 1, and that's graphed below here in red. So so we are given an x value of x is equal to minus 1. And we want to figure out what the slope, or rather, we want to find the equation of the chartreuse tangent line at that point. However, we do not have a y value for that point. So the thing I just had here was a question mark, and we need to figure out what that y value is on the red graph. So how do we do that? We're going to take our x is equal to minus 1, and we're going to plug that into our function here to get the corresponding y value on the graph. So you have f of minus 1, and you plug that into your x cubed plus 1. So you have minus 1 cubed plus 1. That's equal to minus 1 plus 1, but that's equal to 0. So that's the corresponding y value on the graph. All right, so that's the point. You probably could have guessed that y value just by looking at the graph. But most of the time, you're not actually going to be given a graph as we have below, but I'm using the graph to illustrate exactly what we're after. We're trying to find the equation of that chartreuse tangent line passing through the point -1, 0. Okay, so now that we have a y value, we can now use the steps that we have below. So our first step is going to be to find f prime of x. But first, before we do that, notice here that I have my function given. I just rewrote it. I have x0 is equal to minus 1. That was the point we were given. And now we have a y0 to go with it. That was the thing that we found above, namely this. So our y0 is 0. Okay, now we can find the derivative using the power rule. So we have f prime of x. How do we find f prime of x? Power rule. You take your 3, you bring it down in front, subtract 1 from the exponent. So that gives you 3x squared. Okay, that's the derivative of the first term. The derivative of the second term, since it's a constant, is just 0. So you say plus 0. But you really don't need to write anything if you're just adding 0, right? So you can just erase that. All right, so that's our derivative of our given function. 2. Step 2 is we're going to plug in the point given here into our function to figure out what the slope is. Or plug it into our derivative, rather. So we have 3 times minus 1 squared. So minus 1 squared is just 1, so this gives you a slope of 3. Derivatives, again, are going to be slope formulas. So what this is the slope at the point x is equal to minus 1 and y is equal to 0. Okay? That tells you the slope of the graph, the red graph that we have above, as well as the slope of the chartreuse tangent line. They'll have the same slope at that point. Okay? So we have 3. Third step is just plug everything into point slope form. So we have y minus y0 times is equal to m times x minus x0 on the right-hand side. And now just plug in all the information that we have. Our x0 is minus 1. So we plug in all that information on the right-hand side. So we have x minus minus 1 here. And then our m was equal to 3. Then on the left-hand side, we have y minus y0. Our y0 was 0. Okay? So how does this simplify? Look at the left-hand side. That's equal to just y. On the right-hand side, we can clean up this minus minus right here, so that becomes x plus 1. So we have 3 times x plus 1. And then what we can do is distribute this 3 to each of these terms. So this gives you 3x plus 3. Okay, so the final answer is y is equal to 3x plus 3, and this is the equation of your tangent line. EQN, equation of tangent line. At the point -1, 0. Namely, it is the equation of our chartreuse line up here at the top. So this is 3x plus 3, and that's equal to y. Okay? If I hadn't graphed that so bad, it would pass through, the y-intercept would actually be correct, but you get the point. That is the equation of the line drawn. All right.